Hey everybody, welcome back to another edition in geometry. It's Mr. Anderson here with you. In chapter 11, today we're going to be talking about section 5, which is areas of similar figures. Shouldn't be too long today, so here we go. Our objectives. Number 1, we're going to find areas of similar figures by using scale factors, and then find scale factors or missing measures given the areas of those figures. Okay, so let's start out with similar figures. So remember we talked about similar figures before. A similar figure, what they have in common is they're the same shape, but they're different sizes. Okay, so that's the key thing, is that they're the same shape, but they're different sizes. And so if you remember a few things here, for example, if we look at the sides, like in this case, this side that's 2 matches up with the side that's 5, and this 15 matches up with the 6. So the ratio of these sides, all the ratio of the sides are the same. So if you look here, 2 and 5, well, that would be a ratio of 2 to 5. We can't simplify that. But if you look at the other side here, you've got 6 to 15. And what could we divide these by? To simplify this, we could divide them both by 3. So that would give us 2 to 5. So you notice we've got the same ratio of the sides. Okay, so their sides are proportional. The other thing that we learned before was something about the perimeter. And so if we look at the perimeter here, what's the perimeter of the first one? We're going to assume these are rectangles. So if this is 15, this is also 15. This is also 5. So the perimeter of this side would be what? 30, 35, 40. The perimeter of this side is 6, that's 12, 14, 16 units. And so if we look at that ratio, remember we did 2 to 5, 6 to 15 was also 2 to 5, and if we look at the ratio of their perimeters, 16 to 40, what could I divide this by? I could divide these both by 8. And so that would give me 2 to 5. It's the same ratio. Okay, so that's what we've learned before about similar figures are the ratio of all their sides are the same, the ratio of their perimeters is also the same ratio. Okay, but what we're going to talk about today is the area. Okay, so this is kind of a simple one. We know how to figure the area of a rectangle, right? So area is length times width. Okay, so in this situation here, we've got what, 15 times 5, right? So the area of this would be 15 times 5, which would be 75. Okay, so that's the area of this one. The area of this would just be 2 times 6, or 12. Okay, so we know that because we have the numbers and we can figure that out real easily. Let's look at the ratio of their areas. Okay, so the ratio of the areas here, wish I wouldn't have drawn that so crooked, but we're talking about area over here. The area of their ratios, or the ratio of their areas, I should have said. Wow, okay. Well, let's call it the area ratio. How about that? And so this would be 12 to 75. Okay, so 12 to 75. Well, what could we do to simplify that down to compare it to these other ones that all came out to be 2 to 5? I could probably divide these by 3. 12 divided by 3 is 4. 75 divided by 3 is 25. And can we do it anymore? Well, this we could divide by 2, but that won't divide by 2. We could divide by 5, but this one won't. So it looks like this is the ratio here of the area, 4 to 25. It's not the same as these other ones, if you notice, but there is a relationship. Okay, and if you look closely, you may or may not have noticed this at this point, but look at 2/5, 2 to 5, and 4 to 25. Do you notice anything there that's interesting? Well, if you were to take this ratio, 2 to 5, and square it, what do you get? 2 squared is 4. 5 squared is 25. Oh, look at this. If we square the ratio of the sides and the perimeter, we get the ratio of the areas. And in one sense, that kind of makes sense, right? Because, you've got, remember what your units are going to be here? Whatever it is, if it's inches, it'll be inches squared or centimeters squared. Okay, so when you're doing area, remember there's this concept of it's two different dimensions here. Okay, so that's why you have areas, centimeters squared or feet squared. So that's what's happening here is you're taking the ratio and squaring it to get the ratio of the areas. Let's look at an example then, or actually here's kind of how they officially say it. So they're just saying here that if these two figures are similar, then their areas will have the ratio that will be squared. Okay, so and I used a rectangle before, but this can be true for any different polygon. Okay, notice here these look like a trapezoid. Trapezoids, it'll work for triangles, whatever. It all holds true for that. So this is just what says there that the ratio is the side length, or that scale factor. Remember, that scale factor was the ratio of their sides, and it's that number squared. Okay, so all right, so now this one, of course, they're going to be tricky to start us off with an example here. But remember how we read these similarity statements? They have to match up. E matches up with L, F matches up with M. So if it says E, F, G, H, we're going here. It's going E, F, G, H. And on the second one, it's L, M, N, O. So it's L, M, N, O. So if you notice, then the G, H over here matches up with the N, O here. So they've turned this second figure slightly to throw us off, but the sides that match up are the 4 and the 12. Okay, so that's our scale factor. And so let's write this over here. So our scale factor is 4 to 12. Well, let's simplify it to make it easy on ourselves. We can divide by 4, so that'll be 1/3. There's our scale factor. I'll write that down. Okay, so our scale factor is 1 to 3, or 1/3 there. Okay, so what we're trying to do is find the area. Okay, now it told us that E, F, G, H, the area is 40. So the area here is 40, and remember that's feet squared. What we're trying to do is find the area of this one. Well, if this is the scale factor, remember the ratio of the areas is this scale factor squared. So what I'm going to do is I'm just going to take 1/3 and square it. So 1 squared is 1, 3 squared is 9. So this 1 to 9, I'll just call that the ratio of the areas. Okay, so that's the ratio of the areas. So that's what we're going to use when we set this up, and you may or may not have remembered when we did this before, we set up a proportion. So we're going to say here that if this is the ratio, 1 to 9, remember that ratio will equal the ratio of the areas, which would be 40. And this one, which we don't know, we're going to call that x. Okay? And so what we end up doing here then is, you remember, if we're solving a proportion, we cross multiply, or a butterfly method, you might remember. So we're going to do 1 times x would just be x, and then 9 times 40, which would be 360. And so that would be 360 square feet, or feet squared. That's our area over here. Okay. So that's what we're doing, is we're just finding the scale factor between the two sides, then squaring that scale factor, and then setting up a proportion with that ratio of the areas to the areas. The ratio of the areas. The ratio of the areas to the actual areas. I think that's probably a good way to say it. All right, let's look at one more. So once again, they've kind of tried to fool us here and switch the figures around slightly. But if you look here, the CD, side CD matches up with side RS. So these two numbers, that's the ratio, the scale factor, so the ratio of the sides. So we could say 6 to 9. We could divide by 3. So this would be 2 to 3. So this is the scale factor. And so again, to find the ratio of the areas, we just take the scale factor and square it. So this would be 4 to 9. So this is the ratio of the areas. And so what we do is we take that ratio of the areas, 4 to 9, and we say, well, that has to equal, which one do we know? We know the area of ABCD is 48, so the area of this one is 48. And so we would say that would be 48 to x. Again, this is the one that we don't know over here. So cross multiply, that gives us 4x equals 9 times 48. And so let's get up the calculator here. Okay, it wants to go over there. I'm going to try to put it there. All right, so 9 times 48, that's going to be 432, so this is going to be 4x equals 432, and then divide by 4. And that gives us 108, so x is 108. And again, remember that's in inches squared. So this would be 108 inches squared. Okay? Good. Okay, so hopefully you're getting the feel for that. The only other type of problem that we're going to do is we're just going to do that same exact thing, but we're going to go kind of the opposite way. So in these last two examples here, we're going to start with the area. We know the areas, and we're going to find out what the missing side length has to be. Okay, so we're just doing this backwards. So remember what we did. We set up the scale factor, squared it, and then solved that proportion. Okay, so remember that. We're going to kind of work backwards here. So let's say, I'm going to write this in here, ABC. The area here is 98 square inches. The area over here is 50 square inches. And notice this side is 14 inches. This side, we don't know. That's our x. Okay, so what we want to do is let's take the ratio here. By the way, here, remember when we talk about the scale factor, it goes in order from whatever you say first. So if the scale factor, they say ABC to RTS, we want to do ABC first or on the top. So when we set this one up over here, we're going to say 98 to 50. Now remember before, when we had that ratio of the areas, what did we do to get that? We had to square the scale factor, right? So that's how we ended up with this numbers, by squaring it. Well, what's the opposite of squaring something? Taking the square root. So we're going to take the square root of this, but if you look, you notice, these aren't perfect squares. Well, one thing that you can do is you can look to simplify this fraction, and remember, if you can keep in mind all the perfect squares, you know, like 49, square root of 49 is 7, and square root of 64 is 8, things like that, that will help you here. So if you look at this, the first thing I notice is I look at the 50 and I say, hey, you know, 50, if I take half, if I divide that by 2, half of 50 is 25, and that's a perfect square. So let's try to divide both of these. Remember, you have to do the top and the bottom both by the same number. And so 50 divided by 2 is 25, and 98 divided by 2, you may not know this off the top of your head, but it will be 49. And if you notice, hey, look, these are both perfect squares now. So now I can just take the square root of both of these, which means I have 7 over 5. Here is the scale factor now. And so now that I know the scale factor, now I can find out what x is. And so again, the scale factor is 7 over 5 equals what? 14 over x. Now this turns out to be a pretty easy one here. We could go ahead and cross multiply like we did before. But if you notice 7, you just double it to get to 14. So obviously 5 to get to x would be just what? Double, or 10. And so in this case, x would be 10. Inches, that would just be inches since we're talking about the side length. Okay, does that kind of make sense? We're going to do one more if you're still a little unsure there. So one more. So again, we know the areas to start out with. So let's write those in here. Area for TUV is 72. And then the area of NOP is 32. Okay. So let's set up that proportion there, or that ratio. So we're going to go 72 to 32. Remember, this is the ratio of the areas, so we have to take the square root to get it back to the scale factor. These are not perfect squares, but again, let's see, what can we divide these by? And again, it looks like we could divide by 2. 72 divided by 2 is 36. 32 divided by 2 is 16. And you notice, oh, 36 and 16 are both perfect squares. So all I have to do is take the square root of both of these. Square root of 36 is 6. Square root of 16 is 4. Now, one thing you notice here too, when we got this to where we could take the square roots, this could be actually simplified a little bit more. They both can be divided by 2 again, right? So we can just divide these by 2. That would be fine to make this final scale factor 3 to 2. So that's your final scale factor. And so again, then we set up a proportion to find x. And so we're just going to say 3 to 2 would equal what? 9 to x. Again, you might be able to figure this out pretty easily because you could just go 3 times 3 is 9, 2 times 3 is 6. But let's just go ahead and cross multiply here. 3 times x would equal 9 times 2. And then we'll divide by 3. And you notice x is 6. And that would be 6 inches. All right. That's going to do it. That's all we're doing today. Just those two types of problems. So remember, if you have the side lengths, you set up a ratio and then you square them and use that new ratio with the areas. Or if you start with the areas, you set up the ratio and take the square root to get the scale factor, and then you can set up a proportion to solve. So that's it for section 11.5. This is Mr. Anderson signing off. Bye.